Virtual impersonations have become an increasing threat nowadays for all the financial institutions. Impersonation fraud is based on a fraudster assuming victims' genuine personal data to access its online banking account. As this is a fraud that is committed directly to the client and with very little interaction with the bank systems, it is very difficult to prevent subsequent financial operations of the fraudster impersonating the client. Improve the security awareness of the clients is a key point. However, detecting any anomaly on the behavior of the client could also help to prevent financial operations of the fraudsters after stealing the client's identity. The goal of the pilot is to explore how next-generation technical solutions like machine learning and supercomputing, together with advanced modeling, could help to create a more accurate, comprehensive and near-real-time picture of suspicious behavior in the financial fraud and cyber-physical attacks, with the final objective of stealing the bank customer's identity and money. The pilot aims to enable operations to address crime more effectively by creating a near-real-time, automated and holistic profile of the customers and behavioral picture throughout the life cycle of a client. The proposed instant loans fraud detection use case is especially interesting for the bank, as instant loans are critical operations that can lead to losses for the clients and the bank and need to be properly secured. The pilot targets some business KPIs such as the reduction of time in the fraud detection analysis, the reduction of false positives, and the number of new detected frauds and the total amount of fraud avoided. There are several machine learning tools and models that banks try to apply to improve their fraud detection capacities, although most of them are built for general purposes and are not especially built for financial fraud. Infinitec will provide beyond state-of-the-art tools on big data management, data anonymization and machine learning algorithms to improve banks' current fraud detection and scoring models. It will facilitate real-time evaluation relying on the actual data, minimizing false positives or negatives, with both improving the user and the bank experience. We have mapped into the Infinitec reference architecture all the different tasks that should be done in the data management and analysis of the pilot. Some of the actions such as data collection, extraction and anonymization will be deployed within the CaixaBank systems, while data analytics and visualization will rely on the Infinitec infrastructure. CaixaBank plans to deploy part of the Infinitec platform and use cases in its Information Security Garage Lab. This infrastructure is a sandbox especially designed to evaluate innovative tools integration into the digital security department's day-to-day operations. It is already defined and under deployment, which will be finished in the first quarter of 2021. The deployment of some of those tools inside CaixaBank premises, even in a laboratory environment, will allow to refine the models extracted in the first phase based on synthetic or anonymized data. Infinitec platform testing will be listed in the set of solutions to be deployed and evaluated inside this testing and training environment of CaixaBank. The Infinitec platform necessary to deploy pilot number 7 will be deployed as a proof of concept in that environment in order to test the tools with real clear data, and evaluate the benefits of this approach on the model definition. More concretely, the objective is to undertake an extended evaluation of the platform and the use cases in the provision of agile and personalized advanced analytics of financial fraud potential cases. Even if the access to this environment will be open to other departments beyond the Digital Security Department, this evaluation will also study the possibility to skip some security and data privacy processes, and to which extent the data synthesization or anonymization of the use cases can be avoided, directly with real clear data when running inside this environment or other locations from CaixaBank. Building an algorithm in data science usually comprises several parts. 1. Understand business needs, done through several meetings. Future iterations could include talks with a subject matter expert. 2. Collect data. Due to data protection issues in this case we resorted to synthetic data. To preserve customers' privacy, CaixaBank provided a synthetic dataset generated from real loan data, preserving feature representativeness. 3. Clean and prepare data. This step determines the precision of the results, and in subsequent work, it will require some more attention. The data assessment revealed some oddities we are still investigating. 4. Experiments with models. To achieve first findings and getting insight into the data, we ran the first clustering without waiting for the end of the previous step. The algorithm is isolation forest, see picture. One starts at the top and each dot is a question chosen by the algorithm. For instance, is the amount greater than X, or is the client no for more than 1 year? If yes, go down on the left branch, if no, on the right branch. It's like a decision tree. The idea is simply, how many questions do I need to ask to identify this loan request? If only a few questions are enough, like did it originate from Ukraine, which returns only one line, the loan is very unusual. If many questions are needed, and at every steps but the last one, many other lines have the same answers, then this line is common. To improve the result, one then averages many trees, 3 in the figure, thus the name forest. Some randomness is added to ensure the trees are distinct. In the next steps we will engineer more features, which will be based on updated and more detailed data, including information like the hour at which the loan is requested. Many more features shall be built with access to these data. Indeed, the goal is to detect unusual behavior, so the more we know about the habits of the customer, her past activity, the more we can define what her normal behavior is and thus contrast it to abnormal behavior. Based on the same synthetic data, also unsupervised clustering was applied. The loan operations analyzed in this preliminary step does not include any information on whether a loan was legit or a fraud attempt. Therefore, our methodology and analysis are based on an unsupervised approach. To have a grasp of the power of the clustering approach, we leverage the Caixa risk classification system. This risk index labels each loan request into different risk categories. Comparing the Caixa index with the detected anomalies, we can measure their accordance as well as estimate the potential of this approach. We first look at how many risky loans the clustering algorithm can match. On the left, we show the percentage of anomalous operations divided into the 3 Caixa risk classes, with 0 representing non-risky operations and 1 and 2 representing more risky operations. It is promising that the clustering algorithm, being a preliminary attempt, can both match a good portion of risky transactions as well as discovering 1.3% of anomalous operations classified as non-risky by CaixaBank. Additionally, on the right we show how anomalous events are distributed across the 3 risk categories, finding that 20% of the anomalies discovered capture operations that were not labeled as risky. In general, even if the clustering algorithm is not able to match all the risky transactions, it could provide interesting insights on new possible frauds that are not recognized by Caixa. Caixa is actively working on providing a labeled fraud dataset that will allow refining the procedure via a supervised approach.